All right, I've been asked to have a look at this one here. This is exercise 14.06 from the Theta mathematics textbook. And I've been asked to do question 19. Again, we have algebraic fractions, in this case, a subtraction. Nice and straightforward one to do, with possibly a few opportunities for cancelling, but we'll find that as we go through. Now, whenever we've got two different denominators, it's quite a temptation just to simply multiply them together. In fact, that's what I'm going to do. So we'll see how that plays out. I can see there's some opportunities, though, for cancelling as we go along. And the reason I can see this is because this is x plus 4. And this here really is a combination of the x plus 4 and x minus 4. Because if I make a little sidebar over here, we know that x plus 4... Oops, my pencil's dying here. I'll just change it. There we go. X plus 4 times x minus 4 is in fact x squared minus 16. So this here forms part of this expression if you included the x minus 4. So I'm just aware of that. There's no x minus 4 here at the moment. But let's just see what happens when we go ahead and we just play around with this a little bit. All right, so let's go ahead and do just that. I'm actually going to leave it, though. I'm not going to actually multiply these together and actually expand them. I'm just going to leave it like that. So I'm going to go x plus 4. Now, you could expand them, of course, because this, of course, is x plus 4, x minus 4. But I'm not going to bother with that. I'm just going to leave it like that just for now. So, of course, x times this is going to be x lots of x squared minus 16. And we've got minus 3 lots of x plus 4, 3 lots of x plus 4. Okay, well, that's really interesting. Because if I was just to, and I can expand this out, I'm not going to, but I'm going to expand this out. Just see what goes on here. So I've got an x, I've got an x plus 4, x minus 4, which is what this figure here is. Remember, we said x squared minus 16. It's a difference of 2 squares. I say it's a difference of squared because really it's x squared minus 4 squared. That's why it's a difference of 2 squares, because 16 is 4 squared. So I'm just going to see how this plays. I got 3 and an x plus 4. There it is. Now, let's see if I've got something common here. So on the bottom, I've still got x plus 4. And I can expand this out here, really. I could say this is x plus 4, x minus 4. Well, that's interesting. Does that help us? Well, let's have a look. So I've got, well, what's common here? On this bit, I've got an x plus 4 over here and an x plus 4 over here. So this expanding that out didn't really help us. But we do have the x plus 4 on the bottom. So I could have left it like that. That would have been just fine. But I can go x plus 4 divided by x plus 4 is 1. So that becomes a 1 there times 1. And this also becomes a times 1 over here. There it is. Because this divided by this is 1. This divided by this is 1. So let's now re-expand that out. So we've got x times, this is x times 1. And all I've got left here is x minus 4. Minus 3 times 1, which is 3. All over. Now I've got this figure here, and I'm actually going to, I'm going to leave it the way it is. So it was an x squared minus 16. Let's expand that out. So I've got now x times x is going to be an x squared, and x times minus 4 is minus 4x minus 3. Oh, that's interesting too. Because remember I had the x squared minus 16, and I actually I put a minus 4 on the bottom here. Well, I can actually see how that actually might play out now. Because if I expand this, and I take this as a quadratic, and I just put a little sidebar over here, we can say x squared minus 4x minus 3 is equal to, well, factors of 3 are going to be 1 and 3. That's all it is because it's prime. So it's 1 and 3. And we've got, put the 2 brackets in, got an x here and an x here. Signs are different. And the biggest one is negative. So I'm going to have a negative in here and a 1 in here. No, so I can't just go ahead and this does not work. Because although that times that equals that, negative 3 and 1 is positive 2. Sorry, negative 2. So we can't go ahead and do this. This does not work. So I was thinking maybe there's an opportunity here to multiply these two together, but there really isn't, which is a little bit of a shame. But that's going to be all right. I can live with that. All right. So let's see what we've got now. So this is going to be equal to x squared. In fact, we can just leave it, in fact, just like that. So that, in fact, should be the actual answer. So I did have a bit of a play around. Notice I had to try and think it through on my feet. Did that work? Was it a possibility? And it was worth, by the way, these paths are worth exploring. So I tried it, didn't work. Go back to here. There's nothing really else I can do. And that would be my solution. Equals it. Hopefully that makes sense.